The new chapter is talking about the sinusoids and the phasors. And here we solve some RLC circuits using that have AC sources using the phasors. So first we have here some introduction to the AC and DC. The DC sources were used for a long time and they provide electric power for until the late of 18th century or 19th century, and the AC is later on was used, and they are more efficient and economical. So what's good also in sinusoids that they can generate a signal that has a sine wave, which is a periodic function, and it has some good characteristic, like for example that the derivative of sine is also a sine wave, but a little bit shifted, which is cosine or cosinus sine and so on. So in general the AC is preferred, especially in high power, than DC. The circuits that has AC circuits, AC sources are called AC circuits. Usually, as the examples that we have solved before, when we have DC circuits, DC sources, we call it DC circuits. So here, this is a sine wave. We know that the main characteristic of a sine wave is that we have amplitude. Here is Vm, and we have the period, which is T. So you have, this is one complete period, and 1 over T is the frequency. 1 over T is the frequency in hertz. T is in seconds, of course. And 2 pi time f, the frequency, is called omega, or the angular frequency. So this signal here is described by this function. It is V of t equal Vm, which is the amplitude maximum, sine omega t. And we can have something also called phase here. We can add a phase, positive or negative. So if we have a phi, for example, here, then we, in general, this is how it looks like. V of t equal Vm sine omega t plus or minus phi. These are some relations, just to remind you, with the relations of the sine and cosine. Like, for example, sine squared plus cosine squared is 1, and sine 2 theta equal to sine cosine. Just to remind you, cosine 2 theta, for example, is cosine square minus sine square. Cosine negative equal cosine positive theta. And sine negative is negative sine theta. Here, if you add, for example, positive or negative 180 degree for the sine, you add a negative for sine and cosine. So 180 degree, you add a negative sign outside. If you have sine angle with a 90 degree, if you add a 90 degree, you convert it to cosine. So if you want to convert from sine to cosine, you need to add a 90 degree. If you want to convert cosine to sine, you add also a 90 degree, but with the opposite sign. So if you want to convert cosine to sine, positive sine, so add a negative 90 degree. So you see here, this is positive negative and negative positive. Here, if you have sine square or cosine square, and you want to represent it in cosine 2 theta or so on, like this. So if you want to remove this square, how do you remove it? You represent it like this. Also, if you have two angles, A and B, and you need to have a sine A plus B or A minus B, or cosine A plus B or A minus B, then this is the relation here. If you have A cosine omega t plus B cosine omega t, this equal C cosine omega t minus theta, where C is A square plus B square under square root. See here, you can convert addition. Here you add A cosine and the sine, and you convert them to one function here, where theta is tan minus 1 theta b over A. Here's an example. Say calculate the phase angle between V1 negative 10 cosine omega t plus 50 and V2 equal 12 sine omega t minus 10, and state which sinusoid is leading, which one is leading. So what you need to do here is to compare them by converting them to the same form, either cosine or sine. So for example, here this is sine, the second one is sine. So let us convert the first one to sine. So first I want to get rid of this negative sign here. So the negative, you can get it on side by adding one here, 180 degree like this. So it will be, you see, negative. I cancel it by adding 180 degree. You can add or subtract. And then after that, to convert cosine to sine, you just need to add 90 degree. See, convert cosine to sine. So here is omega t 50 and 180. It is the same, plus 90. Then you convert cosine to sine. Then you add all this. It will be omega t sine omega t plus 320 degree. You can leave it like this, or you can say that this is negative 40 by adding or subtracting 360, because 320 degree is equivalent to negative 40 degree. And now compare these two. They are in the same form. Okay, forget about the amplitude. You don't care about the amplitude now. This is sine omega t minus 10. So here it is. This is V2, and V1 is negative 40. So of course, it seems that V2 is leading V1 by 30 degree. What is phasor here? Phasor, if you want to solve a circuit, like for example, a circuit like this one here, if you want to solve it, and you have Vs of t equal 12, 20 sine whatever here. So how do you solve it? The only way to solve this is to apply Kirchhoff current law, Kirchhoff voltage law, and then solve a differential equation. Sometimes you don't like to solve differential equation, so the solution here, the nice solution here is to convert it to phasor. So you convert this voltage here to phasor, and then you convert the components phasor. So how do you do that? The method is very easy. That if you have a V of t, for example, like this, V equal V0, this amplitude, and cosine omega t plus phi, then you just need to convert this to this form here, amplitude and phase. So it will be V0 and angle phi. That's it. That's it. Very simple. Okay, so you see here you have, for example, a cosine omega t. Then you convert it to phasor. You just take the amplitude and the phase. There is no phase here, so it's 0. Here, a cosine omega t plus phi, then it will be a and angle phi. Some people write it like this, of course. I personally prefer to write it a and angle phi. If you have a negative like this means that you need to, if you need to cancel this negative, you add a 180 degree or by. Then in this case, it will be amplitude, which is A, and the angle is phi plus or minus pi. Sine, you need to add a negative to convert it to cosine by adding a negative 90 degree or negative pi over 2. So the amplitude is A, the angle is negative pi over 2. So this, of course, if you want to convert it from sine to cosine. If you have multiple sources, one is sine, one is cosine, then you need to make them stable. You need to either use sine or cosine, so that the result at the end, you will get them in the same format. Let me just explain this. Assume that you have a circuit like this, for example. This is sine here. Okay, so one way to do that is that you say, okay, this is 20, and this sine is supposed to be cosine to convert it to phasor, and you add the negative 90 degree to this 30, this is a phase. So the answer will be in cosine. You can do that. But also, if you have only one source, and this is sine, okay, then the result will be in sine. Then you can say, okay, the phasor of this one is 20, and angle 30. That's it. This is the angle, 20 and 30. And the result will be sine. So this is up to you. But if you have multiple sources, and this source is sine, this source is cosine, this source is cosine, this source is sine, then it is better, of course, it is important that you have all of them either sine or cosine. So here, the standard here is cosine. So you see, when you have a sine here, you can convert it to cosine. So you have a sine, the angle is phi A, amplitude A, and the angle is phi, and you add a negative pi over 2 to convert it to cosine, and so on. If you have a differentiation and integration, it is very easy. You just multiply by j omega or divide by j omega. So the differentiation, okay, then you multiply this by j omega. You see d by dt x of t, you multiply it by j omega and make this x here. And the integration, you divide by j omega. And this helped us a lot. In solving circuits that has capacitor and inductor, because you know that, for example, what is the voltage across inductor? It is LdI by dt. LdI by dt. This is a voltage. Voltage equal LdI by dt. Then you can take this di by dt and then replace it by j omega. That will be j omega times I in phasor. Then in this case, you can say, okay, V equal j omega L times I. J omega L times I. So this will be similar to what? To Ohm's law. J omega L is resistance, call it resistance here, time I. Okay, and so because this is this has complex numbers, we call it impedance. Not resistance. Resistance is always real, but here this is impedance because it has imaginary number. For capacitor, for example, what is the voltage? The voltage is the integration, 1 over c integration of IDT. So the integration, you remove the integration and divide by j omega. So it will be 1 over c times j omega. So you can say 1 over j omega c times what? Times the current. So voltage equal 1 over j omega c times the current. Then you can say, okay, the impedance of the capacitor is 1 over j omega c. Then in this case, instead of differentiation and integration, you convert it to just multiplication and division. So it will be just algebra, not differentiation and integration at all. Okay. These are some known relations for the complex numbers, that any complex number has a real and imaginary, z equal x plus gy, and it has amplitude z and the phase theta, where this z is the square root of x squared plus y squared. Okay, these are here, we call it r, and theta is tan minus 1, the imaginary over the real. Okay, so you can represent it like this, you can represent it like this, you can represent it like this, up to you. If you want to convert it back or if you want to find x and y from z, you can say, okay, x equal r cosine theta and y equal r sine theta. This, when you see this something like this is called z conjugate. This one is the same like z, but with the negative of the imaginary. So you add negative to the imaginary. This is z conjugate. If you multiply two imaginary numbers, you multiply the amplitudes and add the phases. So you see here, z1 times z2 equal r1 times r2, and the angle is theta1 plus theta2. If you divide, then you will divide the amplitudes r1 over r2 and you subtract the phases. That's it. So these are just general relations here for the complex numbers. If you have e to the power of j omega or j phi, for example, this is cosine phi plus j sine phi, or minus, of course. If this is minus, it is minus. If it is plus, it is plus. This is an example here. We need to transfer some functions, like, for example, 6 cosine 50t minus 40. Okay, so if you want to convert it, so this is the amplitude, it is 6, and the phases, negative 40. That's it, 6 and negative 40. And we usually, when you have function of time, we use small numbers, I of t, and if we have use a phasor, will be capital. Here V equal 4 sine. To convert from sine to cosine, you just add a negative 9 and 90 degree. Then the amplitude will be 4, and the phase will be 50 minus 90. Minus 90. That's it. This V equal negative 7 cosine. Okay, so it is cosine. So the amplitude here is what? Is 40. The amplitude is 7, sorry, 7. And what is the phase? The phase is 40. And you have a negative here. You can add it inside by adding plus or minus 180 degree. You can add either positive or negative 180 degree. So the amplitude is 7 and the phase is 40 plus or minus 180 degree. Here I equal negative 4 sine. Okay, so again the amplitude is 4 and the phase equal what? Since this one is 10, so it is 10, and you have sine. Okay, sine is plus or minus. From sine to cosine, you have to add this one. You need to add actually 180 degree, and then you add a negative 90. Convert from sine to cosine. So 180 degree minus 90 would be adding. You add a 90 degree. So this will be the angle here. So it is so simple. The idea is so simple. Here you have, for example, V equal J8 e to the power of negative J 20 degrees. So the amplitude is 8. The amplitude is 8. What is the phase? J by itself is 90 degree phase. J by itself is 90 degree phase. So you add 90 degree to this negative 20. That's it. You add 90 degree to this phase 20, negative 20. And since this one is phasor here, then it is cosine. So if you want to convert from phasor to time domain, will be 8 cosine omega t plus 90 degree because you have this J and minus 20 degree. If you have I equal negative 3 plus G4, so you need to convert this first to amplitude and phase. What is the amplitude? The amplitude is the real square plus the imaginary square under square root. So it will be 3 square, negative 3 square, which is 9, plus 4 square, which is 16. So it is 25, under square root will be 5. So this is amplitude. What is the phase? The phase is 10 minus 1, 4 over negative 3. So this is the angle. You will see that this angle here is 126.87 degree. So this will be I of t. If you have it like this was very easy. The amplitude here is 25. Negative, you can move it inside by adding 180 degree, okay, or minus 180 degree. So the amplitude is 25, and it is cosine omega t, and it is 40 plus or minus 180 degrees. So that's how we convert this function from phasor to time domain, and so on. So again, if you want to convert components, resistor, capacitor, inductor, from time domain to phasor domain, for R there's no difference. V equal I times R. In phasor domain, it is V, capital V equal capital I times R. There's no difference because it doesn't have any complex numbers. It doesn't have any integration or differentiation. But for the inductor, I know that V equal L di by dt. In phasor, it is just multiplication. It will be J omega L time I. So here we say we can replace this one by impedance, and the impedance is J omega L. J omega L. And we deal with it as if it is resistance. So V equal I times this Z here, which is the capital Z, impedance. And for capacitor, again, it will be the voltage here. Why? I don't know why they make it like this. It's supposed to be V. This V equal 1 over C integration here. So the impedance here is 1 over J omega C. 1 over J omega C. Here it is. ZC is 1 over J omega C. Then you can replace the capacitor and inductor by their impedances, and after that you deal with them as if they are very similar to the resistor. The impedance, so the impedance Z of the circuit is the ratio of the phasor voltage to the phasor current. So it's the same like in resistor, it is V divided by I. This is impedance is an ohm also, and it has real and imaginary. Real is the resistance and X is called the reactance. Okay, and the admittance Y is the reciprocal of Z, 1 over Z. Okay, and the conductance G is conductance and B is substance. Okay, so here is a series and parallel impedance. You would deal with them exactly like resistors. There's no difference at all. For example, if we have this example here, and I want to find V of t and I of t. So how do I do that? You convert this to what? To impedance. This is 5 and this is 1 over j omega c. 1 over j omega c. So this will be 1. The impedance, the capacitor is 1 over j. Omega is what? Omega is 4. This is omega. This is omega. 40. So first Vs is what? Vs is 10 and amplitude, our phase is 0. There's no phase. So it is 10 and phase 0. And omega here is 4. So it will be, and so this one 1 over j omega c. So it is 4 times c. So it will be j 0.4. Okay. Of course, 1 over 0.4 is 2.5. And 1 over j is negative j. So it will be, you can say this is negative j 2.5. You can write it like this. That's not a big deal. Okay. So 1 over 0.4 is 2.5. And 1 over j is negative j. 1 over j is negative j. So if you move j from the bottom to top, you just add a negative sign. So in this case, these two here are in series. So they will be what? They will be 5 minus j 2.5. This is what we have here. And then you can convert them to amplitude and phase. The amplitude is the square root of 5 square plus 2.5 square. So you get the calculator, and then you say 5 square, which is 25, plus 2.5 square, where's the square, equal, okay, and you add this to the square root of this, equal 5.59, and this is negative 2.5 divided by 5, which is, so 2.5 negative divided by 5 equal, and this is the inverse 10, inverse 10, so the angle here is negative 26, 5.565. So this is the angle for Z. Okay, this amplitude and phase. So if you want to calculate the current, what is the current? The current equal voltage divided by resistance. Here, voltage divided by impedance. So the voltage here is 10 and 0. And the amplitude, the impedance is 5.59 angle negative 26.565. So if you have this problem here, how do you do that? You just divide the amplitudes. So it is 5, it is 10 divided by 5.59. That is 1.78, almost 9. And you subtract the angle. 0 minus minus would be plus. So this is the current here. Okay, we got the current in phasor. If you want to convert it back to time domain, so easy, so easy. The amplitude is 1.789. Here it is, 1.789. Cosine, and here this is the angle. You add it here. That's it. And it is the same here, 40, like the original one. The original one was 40, and this one is also 40. Okay. Regarding the voltage across the capacitor here, if you want to calculate V, I want to calculate V, I don't want to calculate I only. So what is V? V equal I times Z, Z times Z. This Ohm's law, voltage equal current times resistance. Here, voltage equal current, the current in the capacitor times the impedance of the capacitor. So it will be I times ZC. ZC here is what? This is ZC. This is ZC, is negative J 2.5. So if you want to convert this to amplitude and phase, the amplitude is 2.5 and the phase is negative 90 degree. J is 90 degree. Negative J is negative 90 degree. Then you multiply it like this. So this is what you have here. actually like this. You're supposed to remove this negative J 2.5 and replace it by this. Then now you multiply the amplitudes. You multiply the amplitudes, and it will be 1.789 times 2.5. Okay? So it will be 4.472. And you add the phases 26.565 minus 90 will be negative 63.4. So that's it. So this is V. V of what? Of V across the capacitor. Okay, but it's not solved here. I don't know why I forgot to complete it. But let us just complete it here. So what's the V of t in this case? Just convert this back to time domain. So it will be here's the amplitude. Here's the amplitude. It is 4.472, and you add a cosine, and you restore the original one here, omega t, which is 40, plus or minus the angle here, negative 63.443 degrees. That's it. So this is the voltage across the capacitor. This is the voltage across the capacitor. That's it. Done. Very easy.